Hey guys, welcome back. So in the previous videos we looked at inheritance and polymorphism. Now those are very useful, but in some cases you don't want to have that kind of ability. So to show you what I mean, suppose we go to our teacher class and let's define another variable. Let's define an integer that represents the number of years the teacher has been working at a particular school. Int num years at, and we'll pass in this integer, num years at school right here, and then all we're going to do is we're just going to do num years at school is equal to the value of that parameter. Okay, and now let's define a function that calculates the salary of the teacher based on how many years the teacher has been at the school. So let's say public int get salary. Let's refactor this mSalary method to the base salary. So every salary, when they first start the job, they might make a certain amount of money, and every year after that, they're going to be awarded a little bit more. So when we do that, what we're saying, we're going to be passing in this base salary in our constructor, and we're going to be passing in the number of years the teacher's been working at the school in our constructor. In this getSalary function, we're going to calculate their actual salary. And for now, let's just say that their salary is going to be the number of years at the school times $1,000 plus base salary. And let's see here. So remember from our previous videos, why do we get a compiler error? Well, the number of years at the school is an integer, and then we're adding it to this double. So we're doing an integer times 1,000, which gives us an integer, but then we're adding it to a double. Well, an integer plus a double is still a double because we want to preserve the high precision functionality given to us by the double. And so we're getting a compiler error because we're trying to return an int. If we change this to a double, we're going to be fine because now, it resolves to a double and we're returning a double. Anyways, so that's what this function does. And we can test this out really quickly by creating a teacher called Sally. This Sally, born on 04/25 or 24, 1970 maybe, and the school is UCLA. And then, so then the base salary, it's a double. Let's just say it's, 50,000. 50,000, and then she's been teaching at UCLA for 10 years. Okay, so then according to our formula, that should be 60,000. She should be making $60,000 a year now. So then we do system out print line salary dot get salary, run, and we get 60,000. Okay, fair enough. Now suppose we're writing our code and we decide we want to create a new type of teacher. This teacher is going to be called, or this teacher type, let's say it's called a student teacher. So a student teacher is a teacher who's just learning the ropes, they've just started working, and they have this particular quality that every student teacher belongs to another school. Student teacher school. So for example, while Sally teaches at UCLA, she belongs to UCLA because that's where she teaches. But we could have this student teacher named Mike, and he's getting his degree from maybe like UC Davis or another school. And so that's his school that he belongs to. So he's not really a teacher because he's trying to teach at maybe like UCLA, but he's from another school. Okay, so this is our custom field. And we can define our constructor, student teacher, string student teacher school. Here, actually, an easy way to do this is a good tip. In Eclipse, you can do right click, and then you can go to, where is it? Source, here we go. And then we can do generate constructor from superclass. So what this is going to do is it's going to go into the superclass. And did we extend teacher? No, we have not extended teacher. So we're going to extend teacher because every student teacher, is a type of teacher. We're getting a compiler error. Oops, let me remove that from now. I'll get to why we have that in later. And now we're getting a compiler error because we need to add a constructor. And that made it easy. automatically generated our constructor. Let's indent this a little bit, and we'll add this in student teacher school. Okay, so now student teacher school is, rename that student teacher school. And now if we run this, I mean, this is pretty standard behavior. We can just create our student teacher. Mikey is equal to new student teacher, and then we can do name is Mikey, birthday is 04/24/1990, school is UC Davis, salary is so he's a student teacher. He's not making very much. We'll just say $20,000, and then he is from. So let me rearrange this. So he's trying to teach at UCLA, and he's from his current school that he's at is UC Davis. And then we can do this, system.out.println Mikey.getSalary. And if we do this, we should see that his current salary is $21,000, and yeah, we get that. Okay, but now suppose suppose we have two different programmers working on this project. So one programmer, he's writing all the code for this teacher class, and then another programmer is writing the code for the student teacher class. And they're adding in all of these functions and abilities to each of these classes. But say that one day, the student teacher, this is the programmer working on this class, he wants to change this get salary function. So let's say that he mistakenly thinks that each student teacher should make $2,000 instead of $1,000 for every extra year. Suppose he just gets that information, and that information isn't correct. Every teacher should always be making this much money. But suppose he tries to implement this method. Well, if he does, all he has to do is he can go source, and then he can override or implement the method, and there's this get salary function. It's easy to override, and now all he can do is he can do that really easily. Just add it on $10,000, and we run this, and the Mikey is now making $31,000. Well, this behavior is incorrect because this might be a security concern actually, because every teacher shouldn't be making that much. Every teacher should be making their earnings based on this formula right here, and this formula should probably never change, or change should change like not frequently at all. So in order to get that desired behavior, we can declare this function as final. What this means is that we can't override this function inside of subclasses. So now if this other programmer, he's working on the student teacher class, he attempts to override this get salary function, well, he can't really compile anymore because this function was declared final here, but now he's trying to override it. And that behavior isn't allowed, so the only choice available is to delete it. Now we run it, and we get our behavior of $21,000. All right. Let's say, though, just for the sake of argument, that this teacher class, we've implemented it so thoroughly that we know it's never going to be changed again, and actually we want it to never be changed again. We want it to always stay in this particular format. We don't want anyone to have the ability to create like student teacher classes or other type of teachers. In order to get that kind of behavior, we can declare the entire class as final. What this does is it makes it so that we can't extend teacher anymore. We can't subclass teacher. So we're going to get a compiler there and there because we've tried to create a student teacher class. Alright, so that wraps up this short discussion on final. I'll see you guys in the next video where we're going to continue discussing polymorphism and object-oriented programming, all that good stuff. Alright, see you guys then.